Hi everyone, so let us do another problem. This problem says that we have been given an integer array again comprising of n elements. Okay, this time we have to find length of longest subarray with sum equals to 0. So guys, let's pause the video and try and understand how this question is different from the last question. Let's do that. Okay guys, in the last question we just had to detect whether or not there is a subarray with sum 0. Here there might be different subarrays having sum 0, right? But I am interested to print the length of the longest one. That is what I need. Okay. So definitely there is a brute force way to solve this problem. I can consider all the subarrays out there, okay, and out of all the subarrays there will be n square subarrays, right? So all those subarrays which have a sum of 0, I'll detect the length of the longest one and that would be my answer, right? But can I solve this problem in a bit efficient manner? Maybe think what kind of tweak would you introduce in the last approach. So let's just pause and think over it for a while. Okay guys, so this is quite similar to the problem that we did in the last lecture. You just have to add one simple thing to it. Okay, so I'll take a sample test case. Let's say you have an array containing 2, 1, 4, minus 3, minus 2, 3, minus 1, minus 2 and 6. Can you tell me what will be the answer over here? Just pause and think over it. Okay guys, so here when I look at the subarray from 1 to this minus 2, then you will be able to see that this sum is 0. So 1 plus 4 is 5, minus 3 is 2, 2 minus 2 is 0, 0 plus 3 is 3, and then this is minus 3. So this entire sum is basically 0. And what is this length? So this length is equals to 7. And if you want, you can go ahead and detect all the other subarrays out there, but this is the one whose length is highest among all those that have a sum of 0. So here my answer should be 7. Okay, now how to solve this question? So one thing that I can say is that tracking prefix sums is definitely going to be useful, but you have to make some improvisation on top of that. Let's pause and think what that improvisation could be. Okay guys, as a first step, let's list down the prefix sums at different indices. So if I list down the prefix sums, there are 2 here it is 3, 3 plus 4 is 7, 7 minus 3 is 4, 4 minus 2 is 2, 2 plus 3 is 5, and then you have 4, and then you have 2, and then you have an 8. So these are the different prefix sums that you have. Now guys, one thing that I know for sure is that if a prefix sum repeats, then the part that comes after this till here, okay, that is if I write down the indices are 0, 1, 2, 3, 4, 5, 6, 7 and 8. So when I look at 2 as a prefix sum repeats here and here. So I can say that the part that comes after 0 till this 4, which is from 1 to 4, will definitely have a sum of 0. So let us check that. This much of part is from index 1 to 4 and this sum is 0. If you carefully take a look, this is 5 and this is minus 5. Similarly, I can see that hey, this 2 is again repeated here. So from index 5 to index 7, which is in this part, the sum will again be 0, and yes, that is the case. Similarly, if you look at it from a different angle, you will say that hey, there is a prefix sum over here and the same prefix sum is over here again. So you would be tempted to say that okay, again the part that comes after this 2 till this 2, which is from index 1 till index 7, will also have a sum of 0, and yeah, that is the case. So guys, the point is that a particular prefix sum could be repeated at multiple different indices, right? Now, if you pick any pair of repetition, then the part that lies in between them will definitely have a sum of 0. But let's think a bit critically. Like here, this also had a sum 0, this also had a sum 0, this also had a sum 0. But which one was of your interest? This last one was of your interest because this had the largest length, correct? So now think of it in this manner. If I give you a random array, and in this array, let's say a particular prefix sum, let's call it x, repeats at different indices, let's say at these positions. So when it happens, then I can clearly say that, hey, if this x has come here, that means the part from here to here must be having a 0 sum. Similarly, because this x again comes here, this part must have a 0 sum. Again, look at it like this also. This x repeated here, so the part from here till here must again have had a 0 sum. But can you tell me which pair of x will you consider so that you get the longest subarray with sum 0? Just pause and think over it. So of course I can say if I pick the cornermost ones, my job will get done. So if I pick this x and this x, then the distance in between this x and that x has to be highest. So guys, once we understand this, this can give you a sense of, how the logic is going to look like. So just pause and think a bit more about it. Okay guys, so I'll ask you the same question, but now in a different language. So let's say there was a prefix sum that occurred at multiple indices. It occurred at I, then at j, then at k, then at l. And let's say this was a very long array. Now let's say there is some index m where again this prefix sum repeated. If you have to consider the longest such subarray which ends here and has a sum of 0, then which x will you be interested in? In other words, which occurrence of x will you be interested in? Will you be interested in second, third or fourth occurrence, or will you just be interested in the first occurrence only? Just pause and think. The answer is you will strictly be interested in the first occurrence only, because the distance from here to here, or the distance from here to here, or the distance from here to here, all of them will be smaller than the distance from here to here. So it might so happen that this x gets repeated somewhere else again, but again you will be interested in measuring this length only and not any other length. So now that we understand this particular thing, I can say that for every prefix sum, I would want to track its index of first occurrence. So I would want to record that if there is a prefix sum which is this, then I would want to know for it that, hey, what was the index of first occurrence of this prefix sum? Because if I know the index of first occurrence, then every time when I subtract this index from this index, then I will be able to get the longest length. Okay, so guys, the basic idea is going to look like this. If a prefix sum repeats, if it repeats, I'll not update its index of occurrence. So let's say you are iterating in this array, computing the prefix sums, okay? And you saw that prefix sum x came for the first time at I. Now in your hash table, you will record x and I. Now let's say at index j, again you saw that the prefix sum has become x. That doesn't mean you will update it. You will never update the entry in the map, because you always want this index to be the index of first occurrence of your prefix sum. Okay, so you'll never update it. Rather, the only thing that you will do is you will measure the distance. I think you can measure the distance very easily, because we all know that if a prefix sum that happened at I again happens at j, then the part which is after I until j has a sum of 0. And what is that length? That length is j minus I. You should not do j minus I plus 1. Why? Because this is not included. You understand that, right? So the part from I plus 1 to index j would have a sum of 0. So I can say that, hey, if a prefix sum is coming for the first time, I'll make an entry for that in my hash table. And if it is repeating, then I'll just measure the gap between the current index and the index of its first occurrence. And if that gap is greater than the previously encountered answers, I'll update my answer. And that's how I'll keep moving on and on. Okay guys, now let's pause the video and think of the implementation of this approach also think of a well-known edge case that we already saw in the last class. Let's do that. Okay guys, so this is going to be nothing different. So when you consider an array which has these elements, here if I write down the prefix sums, there will be 1, 3, 5 and 0. So here you can clearly see that no prefix sum has repeated, but still if I consider this entire subarray, okay, this entire subarray, then this has a sum of 0. Now why that is so happening? Because you have not taken into consideration the contribution of empty prefix. For an empty prefix, the prefix sum will be 0. And now here guys, if you try and compare this question with the last question, in last question, in your hash table, just prefix sum, which was your key, was of some significance to you. Value was never of any significance to you, but here value is of tremendous significance, because the value tells you the index where this prefix sum had first occurred. And isn't that very important? The answer is yes. So I would say that, hey, when you would want to initialize your hash table with the contribution of empty prefix, the empty prefix has a sum of 0, no questions asked for that. But what should be the corresponding index? So guys, if I talk about the indices, to denote this much of prefix, I use index 0. To denote this much of prefix, because it ends at index 1, I use index 1. To denote this much, because it ends at index 2, I use 2, and similarly here I use 3. So what index should be used to denote an empty prefix? Just pause and think over it. Okay guys, so the real answer is -1. And it can be thought in a very easy manner. Because even if you take this example, and when you take a look over here, so you would note that this prefix sum got repeated here. And whenever a prefix sum is repeated, then you check for the distance, the gap, okay, and you will be able to get the correct gap between 3 and this point if and only if you have initialized the index of first occurrence of 0 as -1. And you can see that 3 minus -1 is going to give you 4, that is your answer, right? So the first thing that I need to do over here is I need to initialize my hash table, and I need to make an entry for 0, -1 inside it, saying that -1 is the index of my empty prefix, and for that thing the prefix sum is 0. And that's how I'll keep going on and on. Now I think I have told you this approach in entirety, so just pause and think of the implementation detail. In fact, go ahead and implement it on your own. Okay guys, so let's talk about the implementation. So first let me declare my unordered map. So here is my unordered map, or hash map if you're using Java. Now what I have to do is I'm interested in finding the length of the longest subarray, right? Now the different lengths that you will get at different iterations would be different values. So you need to have a variable which is to be maximized every time. So I would initialize answer variable, which is 0. This answer would eventually be equal to the length of the longest subarray that I have. So now the first thing that I'll do is I'll initialize my map with 0, -1, which is the contribution of the empty prefix. So what I'll do is I'll do map dot insert 0, -1. You know, -1 is the index for empty prefix. Now I'll initialize a prefix sum variable, which is initially 0, and then I'll start my iteration on the array. My first step will be to update my prefix sum, which I can do very easily. And now, as I said, the first thing that you would want to do would be to check whether this prefix sum is coming for the first time or for second, third or fourth time. So if it is coming for the first time, it means it hasn't yet repeated. So there can't be any subarray ending there and having a sum of 0. So if it is coming for the first time, I'll make an entry for it in the map. So if map.find prefix sum is equals to map.end, it just means that it has come for the first time, and because it has come for the first time, that means I know that the index of first occurrence of this is I. So what I'll do is I'll do m of psum equals to I. Okay. On the other hand, else means that this prefix sum had already occurred before some time. Because it had already occurred, so now I should not update the index, right? Rather, I should measure the gap, and if that gap is greater than my answer, I should update my answer. So tell me, what would the gap be? So your current index is I, where this prefix sum is occurring, and its index of first occurrence must have been stored in my map. So the index of first occurrence must be gotten in this manner, m of p sum. Now you would want to subtract I and this, and you just want to update your answer to max of these two things. So answer is equals to max of answer, comma, that. And then eventually you can just go ahead and return your answer. So that's how your job is done. So just pause the video and think about the time and space complexity. Okay guys, so if I take a look here, this for loop is going to execute for n times, and every time you are doing map operations whose average complexity is order 1, so your time is order n. Because you are using an unordered map, so there might be n entries, n different prefix sums. Okay, so your time and space both are going to be order n each. Now again, I'll tweak this question a little bit and check if you can write an updated code on your own. So here, now I am interested in the length of the longest subarray whose sum is equals to k. Just pause and think what to change in this logic. Let's do that. Okay guys, so we have already learned that if the prefix sum till here is x, then you would be interested in checking whether or not there was some index till which prefix sum was x minus k. And there might have been many different such indices, right? Where prefix sum would have been x minus k, let's say this and this. But you would be interested in this one, right? And because your current algorithm is already making sure that your map contains prefix sum along with the index of first occurrence. So let's say you are at a particular index and your current prefix sum is x. Now you'd be interested to check whether or not there was some index where prefix sum was x minus k. And if it was x minus k, my map must have stored the index of its first occurrence. If it had stored, then I would be interested in computing this length and then updating my answer. Okay. So the only thing that will change here in our code is that here I would be interested in checking whether map contains p sum minus k or not. If it contains, then I would want to update my answer if that is possible, because I can get that gap. And then in the next step, because now you have to make sure that every time you keep your map updated. So let's say your current prefix sum has come for the first time at index I, so now your responsibility is to make an entry for that prefix sum in your map as well. So there are these two things that you should be doing. Just pause the video and make the relevant code changes over here. Okay guys, so the only component that will change over here is this part. So instead of this, you would want to write something else, and let me write that out. So first you would check if map.find p sum minus k not equals to m.end. So guys, if this is the case, what does it mean? It simply means that p sum minus k must have occurred somewhere before. Because it must have occurred somewhere before, my map must be containing the index of its first occurrence. So what I'll do is, I'll just update my answer. So I'll say that my answer should be max of answer, comma, the gap. And now what is the gap? So my current index is I, and the index of first occurrence for this thing must have been m of p sum minus k. That's it. Okay. Now this if condition takes care of determining the gaps, but now there should be one more if condition to take care of the fact that if a particular prefix sum has come for the first time, then an entry must be made corresponding to it. So guys, it might so happen, isn't it, that your prefix sum right now is equals to 10, and let's say your k was equals to 4. So 10 minus 4 is 6, and 6 must have occurred somewhere before. But now because this 10 has come for the first time, you must make an entry for this 10, right? So what you will do is you will make a check if m dot find of your current prefix sum, if this thing is equals to m dot end, it means that this prefix sum has come for the first time. So I'll just do map dot insert this prefix sum comma the index of its occurrence. That's it. That's the only line of change that you have to bring over here. Ensure that this is not if else. This is a separate if and this is a separate if. Okay, it might so happen that sometimes this was not true but this was true, or this was true and this was not true. Any combination can happen, right? So you have to take care of that particular thing. Okay, so even in this approach we can understand it, guys, that the complexity is again going to be order n, time as well as space. Important thing to understand over here was that here the value corresponding to any key was of extreme importance to me, because here I want the value to denote an important thing, which is the index of first occurrence, which will help me to determine the answer. Okay, cool.